This is the second mini lecture on chapter 11, dealing with solutions and more. We're going to be tackling molality, which may be new to you, and molarity. I hope you vividly recall molarity. If not, we'll do a quick review. Molarity is, in fact, moles of solute over liters of solution. We use the capital italicized M to represent molarity, and keep in mind the units of your volume are always in liters, otherwise you will get a wrong answer. Next up, we have molality. This is a little bit different because it's moles of solute over kilograms of your solvent. So moles of solute over the mass of the solvent in kilograms. Notice the difference here. We have liters of solution versus mass of solvent in the denominator. We can put this to work almost immediately. We're going to tackle molality here in a fairly simple problem. We're told that we have 24.4 grams of sulfuric acid in 198 grams of water. It's useful to identify sulfuric acid as your solute and water as your solvent. Furthermore, it is worth thinking about, you will have to take 24.4 grams and convert it to moles using the molar mass. And you'll have to take this gram amount of water and convert it to kilograms. Set up a simple ratio and you will have your answer. Moles of solute over mass of solvent. We convert moles of H2SO4, sulfuric acid, dividing by the molar mass and getting 0.249 mole of sulfuric acid. And then in the next step, we simply take that molar amount, divide by kilograms of water, our solvent, and we get 1.26 molality. Just like breaking matchsticks, very easy. However, things can get a little bit harder. Here, we're told we have a 2.45 molar aqueous solution of methanol. Furthermore, we're told that the density of this solution is 0.976 gram per ml. And we're asked to figure out the molality of the solution with these two pieces of information, 2.45 molar and a density of solution 0.976 gram per ml. So they conveniently provide us with the molar mass of methanol. And let's think about what we can and must do here. The first thing we're going to do is we're going to make an assumption to make our life easier. We're going to say we have 1 liter of solution. And if we have 1 liter of solution, by definition, given a molarity of 2.45 mole, that must mean in 1 liter of solution, we do have 2.45 mole. We know we want to find out moles of solute over mass of solvent. The question is, the tricky part here is figuring out the mass of the solvent. So our first step, as it says here, is to calculate the mass of water in 1 liter of solution using density as a conversion factor. So first, we're actually just going to find out the mass of the solution. That's step 1, because that's what we can do, given the data in the problem. 1 liter of solution converted into milliliters, that makes it 1,000 ml, right? And then we have this density of solution, so we can say, okay, in 1,000 ml of solution, we have 976 grams. However, that's solution. Moles of methanol have a mass. So in order to get to simply the mass of the solvent, we're going to have to take the mass of the solution and subtract the mass of the methanol. Let's take a look how we would do that. We take the 976 grams, our mass of solution. We figure out the mass of the solute by converting moles of methanol into grams. and we subtract those grams from the mass of the solution, we get 898 grams of, guess what? Solvent. The mass of water is our solvent. So now we're in good shape. Now we just have a fairly simple calculation left, which is to take our 2.45 mole and divide by 0.898 kilogram of water, and we get 2.73 molality. So we've gone from molarity to molality. Now I want to show you an ALEX problem, which is a little bit different, a little bit of a twist on the things that we've been doing, but essentially all the same concepts. So we're told that a student dissolves 15 grams of styrene, C8H8, in 400 milliliters of solvent with a density of 1.13 gram per milliliter. Now it's careful to note here that this is the density of the solvent, not the solute. And you have to be careful there because that could really mess you up otherwise, right? Okay, but that in a way makes our life a little bit easier for calculating the mass of our solvent because we don't have to do the subtraction routine we did in the last problem. Okay, so what do we need that's not provided in this problem? Well, we need the molar mass of styrene. So that happens to be this number right here, 104.15 grams per mole. And we have another piece of information here we can use, which is we can figure out grams of solvent by simply taking 400 ml of solvent and multiplying it by its density. So that looks like this. 400 ml of solvent times 1.13 grams per milliliter of solvent gives us 452 grams of solvent. So now we only need to calculate the moles of styrene using the molar mass and the grams of styrene. That looks like this calculation. We divide by the molar mass and get 0.14402 mole. So now we can take these mole and divide it by the mass of the solvent in kilograms. And that turns out to be this calculation here, which gives us 0.32 molality. Now notice I did molality first. I didn't have to necessarily, but it's a slightly trickier calculation. To do molarity, we're going to use the moles that we calculated here, which is 0.14402 mole. Now the important thing to note, the other important thing to notice in this problem is that the volume of the solvent does not change when the styrene dissolves in it. That means the 400 ml of solvent is going to be also 400 ml of solution. This is handy for us because now all we have to do is say, okay, the volume doesn't change. We have 0.4402 mole of styrene. We're going to divide that by our 0.4 liters of solution, and we're going to get 0.36 molar. Here's a pro tip. Molality is generally a slightly smaller number than molality. So you might want to just keep that in mind. It's useful when you're trying to think about whether your answer makes sense. They're reasonably close together, but molarity tends to be the slightly larger number. Okay, that's it for molality and molarity.